So this video is on exercise 10E question 5. It says a lorry of mass m kilograms is towing a trailer of mass 3 m kilograms along a straight horizontal road. The lorry and trailer are connected by a light inextensible tow bar. The lorry exerts a driving force of 50,000 newtons. This is the driving force, causing the lorry and trailer to accelerate at 5 meters per second squared. The lorry and trailer experience resistances of 4,000 newtons and 10,000 newtons respectively. And we've got to find the mass. So as I said previously, you want to read the question once to give you an idea of what's going on, and then read it a second time, and the second time you read it you want to draw the diagram out. So lorry of mass m kilograms. So let's have my lorry is towing a trailer of mass 3 m kilograms. So it's towing the trailer. So this is mg and this is 3mg. They're connected by a light inextensible tow bar. So there's going to be a tension in this, because if you read it, it's going to be moving. The lorry is towing the trailer, so there's going to be a tension. So the lorry exerts a driving force of 50,000 newtons. So we've got 50,000 going to the right there. And the lorry and the trailer accelerate at 5 meters per second squared. And lorry and trailer experience resistive forces. So the trailer, the lorry. So this one has 4,000 going backwards, and this one's got 10,000 newtons going backwards. And you can put your reactional forces on there. This is for the trailer, and this is for the lorry. And label your tensions, and that's your force diagram. Find the mass of the lorry and hence the mass of the trailer. Okay, so you're going to be careful about what you do here. You probably want to use, which one should we use? So you can treat it as one big particle like we did in question 1. So if we put it together, we're going to have a weight of 4mg, and it's going to have a total reaction. It's accelerating at 5 meters per second squared, and the t's are going to cancel out. So one t is going to the right, one t is going to the left. They can cancel out. We've got a forward force of 50,000 newtons and a backward force of 14,000 newtons. And so if you do it this way, then the only unknown that we have is m. Okay. So we're going to apply Newton's second law. Newton's second law is force is equal to mass times acceleration. So let's have a look. We're going to do our resultant to the right, and that's going to be 50,000 minus 14,000, because 14,000 is going to the left, and that's equal to the mass times the acceleration. So we're going to have 36,000 is equal to 20m, and so m is equal to 1800. And m, well, that's the mass of the car. So mass of car equals 1,800 kilograms, and the mass of the trailer was 3m. So the mass of the trailer is going to be 3 times that, and that's going to be 5,400 kilograms. Now in part B, they said find the tension in the tow bar. So that's part A done. Now part B said find the tension in the tow bar. It doesn't matter, again, it doesn't matter which particle you look at, whether you're looking at the car or the trailer, sorry, the lorry or the trailer. I'm going to look at the trailer. It's got less forces acting on it, so it's usually better to look at that one. So 3 mg, which we know is 5400 G, and resistive force of 10,000, forward tension, and the reaction on the trailer. So, and this is accelerating at 5 meters per second squared. So if we look at the resultant force going to the right, that's just T, take away 10,000, as that's the force going to the left. And that's equal to, so that's F net, that's our net force, and that's equal to mass, which was 3m, times acceleration, which was 5. And we can put in 5400 as our 3m. So T is going to be equal to, and then if you do 5400 times by 5, that's going to give us 27,000 plus 10,000, and that's giving us 37,000 total newtons, and that's our tension. And as I said, it doesn't really matter whether you look at the lorry or the trailer. So I quickly just do the lorry. The lorry had a forward force of 50,000 newtons, a backward force of tension, and 4,000 resistance. Weight of mg, and a reaction on the lorry. Again, it's accelerating to the right at 5 meters per second, so 5 meters per second squared. So the net going to the right is 50,000, take away tension, which was going backwards, and the resistance, which was 4,000. And that's equal to mass, which was 1800, times acceleration, which was 5. Bringing the T over to the right, it's going to be 50,000 minus 4,000 minus, and 5 times 1800 is going to be the 9,000. If you put that in your calculator, you should get 37,000 as T. So it doesn't matter which particle you look at, you're still going to get the same answer. And then part C is the same as part C from question number 1. And as I said, you just need to, this is just something that you need to learn, that if it says it's light, then the tension is the same throughout, or that the mass of the tow bar doesn't need to be considered. And if it's an extensible, then the acceleration of the lorry and the trailer are the same. Okay, so thanks. That was question number 5 in 10E.